In this video, we'll talk about how to solve these three exponential equations. The reason we call these three exponential equations is because the unknown, the x, is in the exponent. First, let's look at A. 3 to the x equals 8, the easiest case. Since 8 is not a power of 3, in other words, we cannot write 8 as 3 to the power of an integer. We have to solve it in this way. We'll either take the natural log, ln, or the common log, log on both sides. Okay, so here we will take the common log on both sides. We'll have log on the left side, which is log of 3 of x, equals log of 8. The reason we can do this is because the log function is a one-to-one function. Since the two inputs are the same, we can say the two outputs are the same. The reason this step will help us is because we can move the x to the front by using the power rule of logarithm. So you have x times log of 3 equals log of 8. Okay, so to leave x by itself, you want to divide both sides by log of 3. It is just a number. So the exact value of x is log of 8 over log of 3. If you round the answer to a certain decimal, you can use a calculator to find the value. So log of 8, this is log of 8, divided by log of 3. So log of 3 equals 1.893. Let's round it to the nearest thousandths. Remember I said in the first step you can either take ln or log on both sides, and we took log. What happens if we take the natural log, ln on both sides? Well, if we take ln on both sides, we have ln of 3 to the x equals ln of 8. Okay, similarly, we can move the x to the front by the power rule. So you have x times ln of 3 equals ln of 8. Now, similar step. To leave x by itself, you have to divide ln of 3 on both sides. So these two cancel out. So x equals, the exact answer is ln of 8 over ln of 3. If you remember the change of the base property of logarithm, you can see these two values are the same. Again, to round the answer using a calculator, you can do ln of 8 divided by ln of 3 equals, you can see it's the same, exactly the exact same answer. 1.89, if you round to the nearest thousandth, will be 3, right? Now let's look at question B. 5 to the x plus 3 equals 12. We go through a similar procedure. We either take ln or log on both sides. So this time, let's just take log on both sides. So you can move the exponent part to the front. You have x plus 3, this many times of log of 5 equals log of 12. Okay, one way to solve after this step is you can distribute the log of 5 to x and to 3. So you will have log of 5 this many times of x plus 3 times log of 5 equals log of 12. All right, so remember your goal is to leave x by itself. I'm going to subtract 3 log of 5 on both sides. I know it's a very abstract number, but we're going to subtract that. So you have log of 5 this many times of x on the left side, and on the right side you'll have log of 12 minus 3 log of 5. You don't have to do anything. They're not like terms. You don't have to combine them. And the last step, to leave x by itself, divide both sides by log of 5. And you have x equals log of 12 minus 3 log of 5 over log of 5. You can leave your answer like this, and if you want to simplify the top a little bit further, you could, but you don't have to. So this is the exact answer. You can use a calculator to evaluate this value, which is log of 12 minus 3 times, so 3 times log of 5 equals, all right, whatever this number is, you want to divide it by log of 5. So the answer is a negative number, negative 1.456. Okay, now I'm going to show another way to solve this equation. Write down the equation again. 5 to the x plus 3 equals 12. Remember I said the first step you can either take log or ln on both sides. Well, I will still take log on both sides. So I will have log of 5 to the x plus 3 equals log of 12. All right, then move this exponent part to the front. You have x plus 3 times log of 5 equals log of 12. So up to this step is the same. The difference comes from the next step. Okay, instead of distributing the log of 5 to x and 3, I can divide log of 5 on both sides so that the x plus 3 part could be by itself. So you have x plus 3 equals log of 12 over log of 5. Right. To leave x by itself, you can subtract both sides by 3. So you have x equals this weird fraction, log of 12 over log of 5, and this whole number minus 3. You may think this answer looks a little bit different as the answer we had earlier, but not really, because for 3, you can write it as 3 times log of 5 over log of 5, because that's a 1, right? And using the common denominator, subtract these two fractions, you have log of 12 minus 3 log of 5. It's the same answer as our last way of solving it. So same solution. Okay, now let's look at problem C. E to the 5x equals 14. For this problem, remember I said you can, the first step, you can either take the log or ln on both sides. Since here the base is e, it's easier to take ln on both sides instead of log. So what I'm going to do is take ln on both sides. So you have ln of e to the 5x equals ln of 14. Why this is easier? Well, check this out. You can move the 5x to the front. 5x times ln of e equals ln of 14. Well, ln of e is just 1. Right? So the left side becomes 5x. 5x equals ln of 14. So the exact answer for this equation is ln of 14 divided by 5. Or you can say it's 1/5 times of ln of 14 if you want. And to find this answer in the decimal form, you can use a calculator. So 14 ln, whatever that is, divided by 5. You have 0.528 if you round to the nearest thousands. And this is the end of the video. I hope you find this helpful, and I will see you in the next video. Bye-bye.